Now listen carefully. This question is the theory based. Oh, this is question is already I have taken a theory class. I told you this value. Okay. So this will be given specially mentioned. Okay. If it is both are strong acid and base. If both are strong acid and bases. Okay. Acid and base both are strong acid and base. Here it is a hint is given. It is told that you will use this value only. Okay, hint is given, you will use this value only. Okay, so when NaOH neutralizes any other strong acid, this much amount of heat will be released. This much amount of heat will be released when both are strong. Okay, but here being it is a weak acid, acetic acid, it is able to release less. Okay, so why that much amount of less amount is released, that already I told you in my theory session. Okay, in my other video I have told you, if it is a weak, there it will be neutralization, opposite of the neutralization. Okay, neutralization is exothermic process, and salt hydrolysis will be endothermic process. Okay, very good. Okay, I am getting replies. Okay, so during the backward reaction, it is ionization. Forward reaction is what? Neutralization. Backward reaction is ionization. So depending on the both of them, we can identify. It is supposed to liberate this much, but it is liberating this much. Okay, it is liberating only this much. It shows that what it shows. It shows that all energy released is not completely all energy released is not completely available. It is sometime utilized in the backward direction. How much it is utilized? 55.9 minus 50.6. Where it is used, that will be utilized. That will be utilized in the form of neutralization. Okay, in the form of the ionization. So answer will be 5.3. Okay, what will be the answer? 5.3. Okay. How you got 5.3? Simple. Minus 55.9. Okay. Minus of minus 50.6. Just it is a simple solution. Okay. If you know the concept, then it is easy for you. Okay. Minus 55.9 minus of minus 50.6. Then on simplification, how much you are going to get? 5.3 you are going to get. Okay, this is the answer for this question. Is it understood? Okay, now ready for the next question. Okay, here in this question, we are given with the two allotropes of the phosphorus. Okay, phosphorus exists in how many allotropes? Two allotropes. Okay, very good. So there is red phosphorus and yellow phosphorus. Both are available. We have to find out transition of yellow phosphorus to red phosphorus. Main problem it should be with the sign, whether it is minus or plus. That accommodating it in the right sequence will give you the correct answer. Otherwise, you are going to get wrong answers. Okay, people are giving the answers, but they are wrong in the sign wise. Okay. Plus or minus value, most of the people are answering this. Like these questions, when it comes in the examination, what they will do, wrong option only they will give in the starting condition. Okay. Okay, very good. Answers are coming now. Now they are correct. Okay, earlier the wrong answers were displayed. Now it is correct answers. See here. Ultimately, we have to find out the phosphorus oxide. Okay, what oxide? Phosphorus oxide. On combustion of any oxide, any element, on combustion it will give some oxide. We are not worried about what it is, whether it is P2O5, P2O3. That balance is not much important over here. Okay, in entrance exam, one thing is very important. What is the time? Okay, so wherever you can save time, you should save it. Understood? Now here transition of yellow phosphorus to white phosphorus. That means here you should write yellow phosphorus. Here you should write red phosphorus. Okay, so ultimately you make the combustion of any element. when you combust, when you make the element combustion of any, either it is red phosphorus or yellow phosphorus, it is going to give you same molecule. This is what I told you. Allotrope. Allotropes may be different, but molecule is same. Okay. So now this value we want. Okay. Why you should arrange like this? Is it understood now? Yellow phosphorus to oxide. Okay. Yellow phosphorus to oxide minus 9.91 and it is minus 8.78. So this should be the value. Understood? So once answer is here, just what you have to do, by using the Hess law of constant heat of summation, you are going to get minus 1.13. Okay, most of the people answered correctly. Initially, I was receiving some wrong answer of plus 1.13. Understood? So minus 1.13 is the correct answer. Is it understood, students? Ready for the next question? Okay. Okay, question is here we are given with the enthalpy of combustion of the three things. What are those three things? Benzene, C6H6, carbon in the graphite form, and hydrogen in the elementary gaseous form. Okay, these three values are given. By using them, you have to find out enthalpy of formation of benzene. Okay, so in the other class also I told you enthalpy of reaction in my other video lecture, theory lecture of the chemistry, thermochemistry. I have explained how to find out enthalpy of reaction by using enthalpy of formation. Okay, so if you are not able to do that, means there is some conceptual mistake. So then you go through that video, then you will come to know. Okay, the other video named thermochemistry theory session. It is written as thermochemistry theory session. You go through that video. Okay. Now at that time you will be able to solve this question very easily. Here. So this is a rare combination of the enthalpy of formation. Okay. Enthalpy of formation, enthalpy of reaction. Understood? Here we should be perfect in writing the equation, sentence into equation form. Enthalpy of formation of C6H6. So whichever we want to form, that should be written on the right side, as I told you in the theory session, and it should be 1 mole. Okay, 6 moles of carbon and 3 moles of hydrogen. Okay, and this should be in graphite. This I clearly mentioned you. This should be in gaseous and it can be anything at the room temperature. Normally, benzene will be liquid. This equation we need to form. Okay. So how we are forming that you should carefully understand. Okay. So actually here it is sentence form it is given. We need to convert into equation form. Okay. We need to convert into equation form. Now here enthalpy of combustion. Okay. So minus 3270. What is here? Minus 3270 of combustion. C6. When combustion is given, you should write it on the left side and you should balance it by reacting with the oxygen. Okay. By reacting with what? Oxygen. Okay. Then it will give CO2 plus H2O. What it is going to give? CO2 plus H2O. Okay. So 6 carbons are there and 3 H2O. Now carbon and hydrogens are balanced. 6 to the 12 plus 3, 15. 15 by 2. Okay. So for this is the value. Let us take it as a equation number 1. Converting sentence into equation, that to balancing. Okay. Now here it is minus 394. Okay. So minus 394. What it is? Enthalpy of combustion of graphite. It is very easy question. So CO2. Okay. So this value. Then enthalpy of combustion of hydrogen. Here we need to write half H2O. Okay. And it is minus 286. Minus 286. On combustion, it is going to give you H2. Okay. This is equation 3. This is equation 2. Okay. So total we got 3 equation. Our aim is to form this equation. Okay. Now see how to form. Listen carefully. This is a procedural labs. because of the procedural lapse, people are getting wrong answer. Okay. So first 6 moles of carbon. Carbon graphite is on the left side and we want on the left side. But here 1 mole is available. We want 6 moles. Okay. So equation 2 into 6. Okay. Then coming to 3 moles of hydrogen. Equation 3 it is having, but it is need to be multiplied with 3. Where I got this 3? I got this 3 from the this equation, 3 moles. Okay, here if it is 5, then it will be 5. This is equation number, this is to be multiplied, so that you should get it in the required form. Okay, now I could manage this and this, but I need to manage here this one. Okay, so main problem is that I want it on the right side. Here I got it on the left side. Understood? So for that, what you will do, you will multiply with minus. Whenever you want right to be left or left to be right. When you want something on the left need to be managed on the right side and right to be managed on the left side. Then what you will do, you will simply multiply it with the minus sign. What you will do, multiply it with the minus sign. Okay, so equation number 1. And for mole side there is no problem. For mole side there is no problem because it is 1 mole and here also 1 mole. Is it understood? When to multiply with minus, when to multiply with number, when to multiply with plus. If these 3 things are understood, then it is easy to manage this type of questions. Understood? Now second equation with 6. Second equation value is minus 394 into 6. Okay, plus equation 3 value minus 280 into 3, minus of minus, this will be plus, minus of minus, it will be plus. Now this will be 3279. Okay, so on simplification you are going to get answer. On simplification you are going to get answer, and it is plus 48. How much it is? Plus 48. Is it understood, students, how to manage the questions? Okay. Now next question is on the board. This is very important question, tricky question. Until unless you don't think with your brain, you are not going to solve. Make it sure. Okay, so you keep this question with star mark. Okay, so here methane is given, ethane is given, propane is given. What given? Enthalpy of combustion. But main problem is that you cannot manage by these 3 to form this one. Let's see how smartly you will do and solve. Okay, so try to solve it, then I will tell you the trick. Okay, so until unless you don't use your tricky brain, you are not able to solve this question. Very good question, tricky question. So listen carefully. So this is based on the structure. This question is based upon the structure. Okay. Now how it is C? CH4, there is no problem. C2H6 and C3. Actually, this is just given to you, given, I think mostly to confuse you. Okay. See here, CH3 and CH3. Okay. CH3, CH3. When you make the 2 CH3 to undergo combustion, this much is heat released. Please pay attention here. Okay. Now CH3, CH3 both are there, but extra what it is added, CH2 is added. Okay. So when it is CH2 is added, how much amount extra it is released? This difference you will give it to or not. So CH2 combustion value, only CH2 combustion value is going to be difference of these two. Okay. Minus 526.2 minus of minus, that is plus. Okay. 368.4. This much amount will be released only because of this CH2. Okay. So I wanted to form hexane. Listen carefully. Try to understand this trick. Okay. So hexane. Hexane is CH3. I am writing this as a CH2 4 and CH3. Okay. So these two value already I know how much it is. Minus 368. This value is how much? Minus 368. CH3 and CH3, because CH3 and CH3 just now I written or not. Now CH2 into 4, okay, plus 4 into this subtracted value. 4 into this subtracted value. Is it understood? Is it understood, or should I explain once again? See, hexane can be assumed to be ethane plus 4 moles of CH2. Okay, ethane plus 4 moles of CH2. CH2 value, how you determined? By subtracting these two. CH3 will get cancelled. This is the CH2 value. How much it is? After subtracting, you will get. Okay, so if you are doing in this way, 4 into this difference, then you are getting approximately 999. Okay, make a note of it. There are the most chances that not this question, this type of question, structural based thermodynamics question, maybe chances are there this time. Okay, is it understood, students? So answer is somewhere nearby 999. Okay. Okay, now this is another tricky question. Here bond energies are not given. The ratio of bond energies are given. Okay, bond energy of A2, bond energy between A and B, bond energy between B2 are in the ratio of 1:1.5. Okay, and enthalpy of formation of AB is given. We have to find out bond energy of A2. Is this question understood? Now try to solve and let me know the answer. Now they are in the ratio given. Okay, so if I multiply with x, then it will be x. This is also x. Now I will write it as a x by 2 or not. Bond energies. Okay, what I have done, I have converted the given values into bond energies. How they are converted? Into bond energies. Okay, now here enthalpy of formation, again AB, okay, is equal to half B2 plus half A2. Is it understood, students? Now in terms of in the theory class, I told you, in terms of the bond energy, what is the formula? Bond energy of reactant minus product. Okay, so enthalpy of formation of AB is equal to how much it is? Half into bond energy of A2, that is X, plus half into bond energy of B2. So that is X by 4. Already X by 2 is given. Now it is X by 4. Okay. Already X by 2 is given. Okay. Now it will be X by 4. Half of the B2. Okay. Minus reactant minus product. The product value is X. Okay. And it is how much it is? Already I think question value is given. Formation, enthalpy of formation is already given. It is minus 100. Is it understood? So on simplifying, you are going to get bond energy as 400 kilojoules. How much you are going to get? 400 kilojoules. Okay. What is the bond energy of A2? That means X you have to find out. Any doubt about this? So this is going to be on simplification. How much you are going to get? X is equal to 400. X is itself is bond energy of A2. Is it understood, students? Okay, next question. Okay, this question here it is Cl2 gas to 2Cl this much value, I2 to 2I this much value, ICl gas I plus Cl this much value, I2 gas I2 gas. So I2 solid to I2 gas is this much. You have to find out enthalpy of formation of ICl is equal to question mark. Okay. So try to solve this question and let me know the answer. Okay.